Okay, so we have learned now how we crisscross charges to balance out our ionic formulas. We've learned how to name ionic formulas so that we can talk about them. Now we're going to add some extra things. There are a couple of things we can add to this that make ionic formulas a little more challenging. And the first thing that we're going to add is what we call polyatomic ions. So let's think about, what does polyatomic mean? What is a polyatomic ion? Poly means many. Okay, if you've ever heard of the prefix poly, it means many. And we're talking about atomic, so atoms. So we have many atoms, and then we have the word ions. Ions essentially means that it's something that carries a charge. So we have poly, many, we have atomic atoms, and we have ions, which means carry a charge. So we're talking about groups of atoms that are bonded together covalently that have a charge to participate in ionic bonding. So the thing here is that they're bonded together covalently. Now, we haven't learned fully about covalent bonding yet. Other than that, this is some sort of sharing of electrons, whereas ionic bonding is actually that transfer to create ions and then a bond together. So these atoms are bonded together covalently. They're usually all nonmetals, meaning they have electronegativity differences that are pretty close together. But the thing that's special about them is they might need 1 or 2 or 3 extra electrons in order to make that bonding work, which then leaves them overall with a charge. So here are our common polyatomic ions. Your teacher should have a chart like this that you can use on any quiz or test, which means that we don't have to memorize this whole chart. We don't even have to really know a whole lot about each of these individual polyatomic ions or what they mean. We just have to know how to use them. So if you're looking at this chart, we see the charge up here. Okay, so all of these have a -1 charge. All of these ones have a -2 charge. These few have a -3. We have a couple here with a -4. These ones up here aren't as common as we get into higher charges. And then we have one little polyatomic with a positive charge, and it's just a +1 charge. You can use this chart to refer back to from this notes if you need to. Otherwise, like I said, they should be printed in your teacher's classroom or posted on Schoology. So when we're making formulas with polyatomic ions, we need to know that, first of all, most of the polyatomic ions are negatively charged. As we saw in that chart before, there's only one of them that's positively charged. We got to think of the polyatomic as one thing, which means that charge, whether it's -1, -2, -3, -4, +1, applies to the entire unit. So it's kind of like substitution in math. If we have a whole long equation, we can substitute that equation for one letter. Okay, we're thinking about this whole polyatomic thing as one thing we could substitute out for a separate letter. So if we need multiples of that one thing, we have to put that in parentheses and then put the subscript on the outside of parentheses. Remember that subscripts mean, or they tell us how many of the thing they're attached to we have. So if we have O2, it means we have 2 oxygens, 2 O's. But if we have PO4, it means that we have 4 oxygens, but only 1 P. So if we are trying to put subscripts on these, we have to first have it in parentheses to allow that subscript outside the parentheses to apply to all of the things within the parentheses. So for example, if we have calcium with a +2 charge and OH, that's hydroxide, with a -1, we can see that we need 2 OH -1s to balance out our 1 Ca +2, right? We remember that from crisscrossing charges. Instead of doing CaOH2 without the parentheses, we need to do Ca parentheses OH parentheses 2. This means that that 2 applies to everything within the parentheses. It's telling us that I have 2 of these OH molecules. Okay. Now, how do we name these polyatomic ions? you probably noticed on that table that generally the names end in ITE or ATE. So if you think back to the level 2.75 notes when we learned about naming the ones right off the periodic table, they had endings with IDE when they were negatively charged single atoms. These polyatomic ions then have the ITE or the ATE. We have a couple exceptions. Hydroxide, I talked about on the last slide. That's the OH-1, ends in the IDE. And cyanide ends in IDE. That's CN-1. So those two can make things a little bit tricky. But generally, if we see a name ending in ITE or ATE, we don't even need to look at the periodic table because that's our hint that these are polyatomics and we should look at our polyatomic chart. Let's do a little practice. What is the name and the formula of the following? So we have magnesium and phosphate, aluminum and chlorate, lithium and sulfate. We're going to start with the formula. First we have Mg plus 2 and PO4 minus 3. Okay, if we take this 2 and we're trying to get up to 3, I'd give myself 2 of these, which gets me a plus 4. Well, now I need more negative 3s, so now I'm going to try for 2 PO4s. Nope, that's not right. Okay, what we're going to end up doing is crisscrossing these charges. So I bring the 2 down to be the subscript on PO4, the 3 down to be the subscript on Mg, and I'm left with Mg3 parentheses PO4, close the parentheses, and then the 2 goes on the outside. Remember that this 2 means that I have 2 of everything within the parentheses, so I have 2 PO4s. This ends up working well. My Mg3, if I do 3 times my positive 2, that means my positive is a positive 6. 2 times my negative 3, that means my negative is a negative 6. Okay. How would we name that? Magnesium phosphate. Simple as that. We have the first name off the periodic table. The second one, because it's a polyatomic, I look it up. My ending is ATE, and I just write it down. Now, aluminum and chlorate. Aluminum on the periodic table has a charge of plus 3. I look up chlorate. That's ClO3 with a minus 1 charge. When I crisscross these charges, I bring the 3 down on the ClO3 and the 1 down on the aluminum. I get Al. I don't need to write that 1. Parentheses. ClO3. Close the parentheses, and then the 3 goes outside. Again, that 3 means I have 3 of everything within that parentheses. Naming this would just be aluminum chlorate. Again, first name comes off the periodic table, second name off the polyatomic chart. Finally, lithium and sulfate. Li has a plus 1 charge and SO4 has a minus 2 charge. This means that I need 2 of these plus 1s to balance out my negative 2 of the sulfate. So I get Li2 SO4. Okay, now notice this doesn't have parentheses. Why is that? Probably, if we look at it a little closer, we can see that the SO4 doesn't need a subscript outside of it, which means I don't really need to put it in parentheses. The Li doesn't get parentheses on it because it doesn't have 2 of those back-to-back subscripts like the AlClO3 does, or the Mg3 PO4 2. Okay, we don't have 2 back-to-back subscripts, so I don't need to separate them with parentheses. Now to name that one, again, just off the periodic table, lithium sulfate. Okay, you're going to move on and do our next set of notes and then do some practice activities. If you have questions about this PowerPoint, let your teacher know.